Okay, so a little history. I do arcade game repair on the side, and this is a Galaxian PCB. You can see it running up there on my Commodore debug monitor. And one of the ways in which I debug these is to utilize this, and this is a Fluke 9010A microsystem troubleshooter. And what it allows you to do is to tap into the CPU bus on the system that you're debugging. And so this is a Z80 based system. And so I have a Z80POD hooked up to the troubleshooter. And so I can access the ROM and the RAM, and I can do all sorts of memory checks and signature checks on the ROMs to make sure the contents are okay, and I/O port checks and all sorts of other nice things. And one feature I like about the Fluke is that you can write scripts for it. And so rather than having to manually type in everything on the keyboard, I can have a script that I develop for, let's say, this game. And if I ever have to reuse it, to debug another game or something like that, another Galaxian PCB, then I can just plug it in and run the script. Now, originally the developers added this, which is a tape drive, and allows you to keep your scripts on there. But there's, these devices are 20 years old, and there's problems with the hardware and stuff like that. So what's nice about this unit in particular is that it has the RS-232 serial port option. And so what I can do is come over here to my development station, and I can utilize this. And this is the Fluke FIDE. It's basically a program written by James Bright of QuarterArcade.com, and allows you to write native Fluke scripts on your PC, and then compile them and send them over to the Fluke. Now I have a serial cable that traverses up and goes all the way over here. You can see it come down to the Fluke. And so I have to run over there and make changes to the script and then dump them on here, and it's a tedious process. Now I know I can have the laptop sitting right next to this thing, but it's still a pain to have all these different things all plugged in together just to debug this board. Also, this, if I wanted to take this on the job, there's no handle or anything, and it's just, it's a little cumbersome, and I'm afraid to break it, to be honest with you, because it's 20 or 30 actually years old. And so the plan is to take this entire system here, because again this is just another microprocessor based system, and emulate that in software on the laptop. And so this entire system will be running in an emulator, custom emulator that I'm going to develop for it. And then the only missing piece is how to link the laptop to the given pod. And so that's where this comes in. And this is the Renesas RX 62N dev kit. And so my plan is to program this as a USB device, and then I soldered on some extra headers here, and so basically attach or develop another interface board that will allow me to take this pod and plug it into this dev kit, and then take this dev kit and through USB plug it into the laptop that's running this in emulation. And so basically what I plan on doing is just documenting the overall progress of this project, going through, developing the emulator for the 9010A, and then once that's complete, going through the development of, writing the firmware for the dev kit, and then creating the adapter board for the pod, and then being able to see it all work, being able to see it actually run a game and debug a game and whatnot. So it should be pretty exciting. I'm pretty psyched. It's been a project that I've been wanting to do for a long time, so stick with us here, and we'll see the whole process.
So this is a copy of the Fluke service manual, and it's got pictures of basically the hierarchy of the system itself, how it works and everything. And I pretty much have all this emulated in the software in the Fluke emulator. The only thing that I don't have emulated is this guy here, and this is a particular chip. It's a PIA, or peripheral interface adapter, that's made by Rockwell and some others, and basically allows peripherals to interact with the Z80 CPU, which is over on this end. So everything here is in software. I actually have a Z80 emulator running, open source Raise Z80 emulator. And so what I think I'll do is I'll probably cut the cord here. I'll take the PIA and emulate that on the firmware in the dev kit. So I just need to look up for a data sheet on this chip here, figure out how it works, and then basically just incorporate that, emulate it essentially in the firmware.
So here's the Flukem emulator. This is a project actually that I started like 5 or 6 years ago, and then had to shelve it because I didn't have time to work on the USB aspect of it. But I pulled it out and had to work with it a little bit, but got it up and running.
And so what I did was I took all of the USB related stuff from that USB HID example, basically the enumeration and the lower to middle layer stuff, and moved it over to this guy here. And so if you see here, I have pod, and then connect and disconnect. And so I have the Renesas HID example running here. And so if I say connect, you can kind of see over here it says device is opened, manufacturer is Renesas, the product is HID USB demonstration 1.1. So this basically confirms that I can now have this guy communicate to him. Basically he's enumerated, and I can send bytes back and forth. But I still have to basically emulate that chip, the Rockwell PIA, into this guy here. And so I'll have to go ahead and muck with the firmware and see if I can do that. Okay, we're getting closer. I dug up this, found this on the web, took me quite a while, but this is the data sheet for the R6520 peripheral interface adapter by Rockwell. And so there's a bunch of stuff in here with respect to registers and how it all works, reading and writing the various registers so that I can access the different peripherals and stuff. It's quite a pain, but so yeah, so I emulated that in the firmware for the dev kit. And so basically the top level USB HID example code that toggled the LEDs and did all that stuff, I stripped that out and then replaced it with the emulated firmware for this guy. And so that will allow me to, or allow my emulator actually to think that this is an actual PIA device, and then it can read and write to it and manipulate the registers, that exist in the actual chip there, and then send commands out to the Fluke. So it's coming together. There's a few little quirks to work out, but hopefully I can just start stitching these all together. This in addition to the other emulator I have, and then start laying out hardware and see if it all works.
Okay, so short update. All my little pieces came in this week. One thing that's nice about the companies these days is they're willing to give away free parts, or free samples rather, in small quantities. So I needed 2 headers for my dev board here. So Samtech was nice enough to send me those, as well as some header cables for that. So that's great. Many thanks. And then the outputs of these are 3.3 volts, I believe. The Fluke, which is all TTL, is 5 volts, and so TI was nice enough to send me some 3.3 volt to 5 volt level converters. And then lastly, from Tyco, we have the connector that's going to end up going on the edge of the Fluke there. Let me see if I can dump this out. There we go. And so that'll go, I'll plug into that guy there. And so this is all going to end up, that plus this and maybe a couple other stuff is going to end up on a little daughter card that I will then plug this into, and we'll plug into there, and that way we'll be able to have this guy talk to that guy. Hey, so here I'm just making a quick schematic. This is my little mini daughter board, or whatever you want to call it, that's going to connect the Fluke pod to the dev kit here, because the dev kit is outputting 3.3 volts, and the pod is old school. It's old school TTL, which runs off of 5 volts. So I have a couple of level shifters here, and this is the D25 connector that goes to the pod, and that's the connector that goes, the header connector here. So I just made a quick little schematic, and that's kind of what the board is probably going to look like. I still have to move a couple things around. It's a single layer board, so I may have to pull some tricks, actually run some wires and stuff, because it gets really tight over here. But anyway, that's where I'm at now, and then my plan is to actually fab that board here in the lab. Just using, like the toner transfer method and going from there. I've had pretty good success with that, so we'll see. And here's the PCB. Well, it's not done yet, but using the toner transfer method. So basically you print it off of a laser printer onto some photo gloss paper, and then using an iron you can adhere it to a piece of copper clad. And then you rub it under water to get all the paper off, and leaving the toner, which is stuck to the copper, fused onto the copper. And then I'm just using a Radio Shack copper etchant solution, which I think is iron sulfide or something like that. No, it's ferric chloride. And this is just like a warm top that I'm going to use to heat up the solution so that it'll it'll eat away at the copper much faster. So that's about it. We'll run it through this and etch our circuit board. There you go. And there's the finished product. So this looks like that. That's the power terminal, because it requires 5 volts, 12 volts, 3.3 volts. And that's the D25 connector for the pod. Those are my level shifters. And then the cable, so that will plug right into there. And that's it. Let's try it out. Alright, here we go. We have the Fluke emulator running here, and as you can see it says pod self-test Z80 OK. And so here's the Renesas dev kit running. And basically what I did is I emulated the peripheral interface adapter. There's a Rockwell peripheral interface adapter that sits inside of this guy, and it talks to the pod. And so I decided to emulate all of the other hardware inside the software inside the PC here, but that particular piece of hardware, it made so much more sense to emulate it actually within the micro on here. And so it's kind of an emulator talking to an emulator, but it works out pretty well. And so you can see the lights blinking because there's data being passed to and from the pod as it's doing self-checking. But here is the pod itself. This is a Z80 pod. And I took the cover off so that I could hook it up to the my HP Logic Analyzer here and take a look at some signals. It is talking to it okay, as you can see. It passes self-test, and you can probably use it just fine on a board, but it's ridiculously slow. And I think it's just the overhead from this communicating to this, and then that talking to that back and forth. And so I looked over the instructions, and there's definitely room for improvement in both my software and the firmware that I'm throwing on there. So I'll probably play with that, but I'm psyched. It works really well. And just for kicks, let's hook it up to an arcade game. Let's see if we can fire it up that way. Here we go. And so that's the original Galaxian hardware with the Fluke Z80 pod talking to the Renesas dev kit, talking to the emulator. And so there we go. Success. So I think what I'll do now is continue to work on the timings, try to get this to work much faster than it is, so that I can actually use it to do troubleshooting, because I don't want to have to wait when I do read and write commands and everything. And what really would be cool too is there's a wireless addition to this that I have yet to experiment with. So it'd be nice to be able to do that wirelessly too. Have that guy talk to this wirelessly, and then it would eliminate even more cables. So very cool. I'm happy. Things seem to be working, so onward and upward.